All right, class, so this is worksheet 11B, and this will really help us to understand if you understand trig equations or not. Now, let me caution you with chapter 11. So the law of sines is important. Don't neglect understanding the law of sines. Finding the area of an oblique triangle using the formula 1/2 AB sine C, etc. is important. Don't neglect that. Using the law of cosines is important. Don't neglect that. With the law of sines or cosines, figuring out the ambiguous case is important. Don't neglect that. All right, and then also there are a couple key trig identities, and then come trig equations. So trig equations are important, yes, 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 but there are other important things we learn in this chapter as well, and so don't just study trig equations going into your exam or quiz. Remember all the other stuff that we've talked about. All right, let's get into it. Trig equations. So we've got a couple things going on now. We have to take care of not only a change in the possible change in the domain, but also a change in the period. All right, so before I do anything here, I have to take note of this 3 right here. So normally when I would get one normal sine wave from 0 to 360, I will get 3 waves, right? And so the way I figure out the period is I take the normal 360 and I divide by 3, and I now find out that a normal wave is 120 degrees. So this is important information if I'm going to figure out all values from 0 to 360. Okay, so at this point, you have to figure out, okay, how do I apply this 3 and how do I get the value? So 3x is going to equal sine to the -1 of 0.3458. You cannot move that 3. So you're going to have to use your sine to the -1, 0.3458. I'm punching that in. Sine to the -1, and I got 20.2 degrees. So the measure of 3x equals 20.2 degrees. It is now at this point that I'm going to divide both sides by 3. And now I'm going to get the measure of angle x equals, and I just left the 20.2. I didn't round it off. I left it in my calculator, and I now divided it by 3, and I'm going to get approximately 6.7 degrees. Okay, so there is my first angle, and I know my first solution is 6.7. But what I have to understand is that I'm going to get 3 waves in the course of 0 to 360. And within one wave, I'm going to get 2 values. So let me go up here for you right now. We're dealing with the sine, so let me go up here. So please understand that this is now 120, right? This is 1/3 of it. This is now 60, right? This is 30, and this is what, 90? All right, see how we get a full wave from 0 to 360? So when we got that 6.7, we are somewhere in here, right? And the 6.7 is that gap. So again, you can trace it radially, but again, you got to be careful, and I'll show you how to do that and finish that off in a minute. But or horizontally, let me go the radial way. So here's what I want to do. I want to set this up 0, right? And all the way around is 120. Halfway around is 60. Half of the 60 is 30. And then, of course, you can see each increment is 30, so that's going to be 60 plus 30, or 90. See how I'm set up right now? Okay, now I'm going to do this 6.7. And we're in here at 6.7. And again, I'm doing the sine, and the sine is the opposite, which is positive, over the hypotenuse, which is positive, right? We had a positive 0.3458. All right, so that was our first value, 6.7. So where else is the sign positive? Well, the sign is also positive in the second quadrant. So let me use a little color here, go red. And again, the 6.7 is there. Now be careful. How much is it from there to there? We'll go all the way to the 60 and back up 6.7 less. And what is that? 53.3 degrees. So there's a second value, 53.3 degrees. So there are two values, main values. Now, here's the other thing that's involved. We have coterminal angles. So let me show you over here where we're at. So the 53.3 was this value right here, right? Right here, which was the 60 minus the 6.7. But here's the thing. The wave goes another 120, right? Which would make this at 240. And the wave goes another 120, which would put us at 360. So let me show it this way. Here's the 6.7. How many degrees is that? That's the 6.7 plus 120. So let me use some green here. So I'm just going to add 120 to this. And now I'm up to 126.7. That's a second value due to the second wave of the three waves within the 0, 360. So that was right there. And I got to go again another 120, just be patient there, to that one, which is going to be this 126 plus an additional 120 for a 246.7. Okay, so those are the three values off of the 6.7 because there are three waves. Now let's get the three values off of the 53.3. Oh, well, let me show it to you radially as well. So here I am at 6.7, go around another 120. So see now how you're at 126.7 and go around again another 120, right? And now you're at the 246.7 radial view. Now let's go to the 53.3, which is right here, right? 53.3 is to here. Well, continue around another 120. So again, you're going to take your 53.3 and you're going to add 120 to it for 173.3. Okay, so that's our second, 173.3. Let me show that to you radially. So we were here. Notice how we're on the downside of the curve? So let's go to the downside of the curve right there. And that's where that 173.3 is. Right? And then again back over here to radial. So now at 173 and go around another 120, right? Another 120, and I'm at 293.3, and that's our last value, 293.3. And again, radial, again from here, go down to the back side of the curve, which is this value right here, which is that 293.3. All right, tricky, maybe. I think most students do the radial view. Makes a little bit more sense on these and a little safer. And I'll do the next one with just the radial view, but that's your thought process. And there are your 6 solutions to number 1. All right, fun. Let's do the next one. Number 2. All right, let's note we're at the cosine. Note we're at from 0 to 360 for the domain. We need to isolate the cosine function. So we're going to divide both sides by 5. It is now at this point that 2x will equal cosine to the -1 of -3/5. So I'm going to punch it in my calculator. 3 divided by 5, make it negative. Inverse sine, inverse cosine. 1, let me punch that one more time. Make sure I am good. 3 divided by 5, negative inverse cosine. Okay, 126.9 degrees. 126.9 degrees. All right, so 2x equals 126.9 degrees. And I've got to divide by 2, right? And so we're going to get the measure of angle x to be approximately 63.4 degrees. Okay. Let me also take note, I should have done this ahead of time, of the period. Notice this 2 here. So we get 2 waves from 0 to 360, and the period is 360 divided by 2, or 180 degrees. So I got an answer at 360. I'm going to go another 180. So I got 63.4, but I will have another at 180 degrees more. And so my second value is going to be 243.4. All right, let me show that to you radially. All right, so before we do anything, we got to set up the scale. So 0 and all the way around is 180, right? So halfway around is 90. So a quarter is 45. So 3/4 is 90 plus 45, or 135. So you got to be careful there that you set it up correctly, because this is now a complete revolution is 180, right? Not 360. Okay. So now when you do your, 63.4, you are in here, right? This is 63.4 degrees. So careful now. The reference angle is 90 minus 63.4. So the reference angle is, let's just punch that in, 90 minus 63, I did 180. 90 minus 63.4, 26.6 is the reference. Just hold on that. We'll use that later. Okay, but anyhow, here's my, so there was my first, 63.4, right? So remember, from here, go around another 180. And that's why I added that 180 and got my 243.4. Okay. Now I got to get that second possible angle within the first period. So take note, your cosine was negative here, right? Was the adjacent was a negative over the hypotenuse, which was a positive. Where else is the cosine a negative? And that is in quad 3. So this is where that 26.6 becomes important. And remember how reference triangles always go to the x-axis. So this is 26.6. So how many degrees is this angle all the way to here? It's the 90 plus the 26.6 reference. So add that up. What is that? 116.6 degrees. Now you got to be careful. That is tricky. 116.6. So how do you get the second angle off of that one? Because now again, remember, this is where we're at. Watch, I'll do it to you this way. You get your cosine. Remember, this is only 180 degrees, and it's going to go again to where we get to 360. So this 116, I'm back here again, look right here, right? Now again, from 116, I go around another 180. And what is that? 296.6. And there are your 4 values for number 2. Tricky, yes. I hope you're understanding. I hope you're taking some time to understand. All right, let me do the third one. Yeah, I don't know that I need that radial view, but I'm not going to get rid of it, just in case I feel like I need it. All right, let's do number 3. Okay, so again, I got to isolate the sine function. and therefore I'm going to add a positive 6 to both sides. That's going to give me a positive 2. I'm going to divide both sides by 4. So I know that 2a is going to be sine to the negative 1 of 1/2. All right, and so sine to the negative 1 of 1/2 is 30 degrees. So 2a equals 30 degrees. So a is going to be 15 degrees. Agreed? 15 degrees for a. Now, I got to be careful. I've got a couple things going on here. I've got a period of 2. I'm sorry, I get 2 waves in every normal 360, right? So I get a period of 180 degrees, right? 360 divided by 2. So I'm going to have 2 from 0 to 360. So how many am I going to have from 0 to 720? And the answer is 4 waves. And remember, we get 2 solutions per wave, so I'm looking for 8 solutions here. Okay, so let's set up the radial view. I know 15 is an answer. And I like to get all the other coterminal values off the 15. So let's set up our radial view. All right, what's our period? 180, so this is 0, 180, halfway, 90, quarter, 45, 3/4, 135. Okay. Now let's put our 15-degree angle in. It's somewhere in here, right? 15 degrees. Again, notice the sign here is positive because the opposite is positive and the hypotenuse is positive. Okay, so I have a 15-degree angle. Now let's get the next coterminal angle. Well, all I have to do is from 15 add 180. So I'm going to add 180. And when I do, I get 195. There's my second angle. But I want to spin around again. So I'm going to add another 180. I'm going to keep going till I use up or go past the 720. So that's 5, 7, 275, 375. So I have a 375 angle, right? And guess what? I can spin around again. Another 180, 5, 5, 5, 555. Now if I spin around again, watch what happens. 5, 3, 7. See how I'm past my domain? So I can't spin around that next 180. And again, notice I have 4 waves, and notice I got 4 values off of that first 15 degrees. So I have 4 waves. I got 4 values off of that first 15 degrees. All right, I need to clear this to show you the next one. So it's still 135. This is still 0 and 180. Okay, so now I need the coterminal angle. So again, here we were at 15. The opposite was positive. The hypotenuse was positive. The sine was positive. Where else is the sine positive? And that is in quad 2, right? So here's my reference triangle, right? And the 15 has to go there. So how much is this? That's 90 minus 15, which is what, 75? 75 degrees. So there is now my first one here of what should be 4. Now again, notice, spin around 180 more. So just add 180. So now my second one is at 255, right? 255. Spin around again. So let's go around from there, another 180. And we are at 435. Let's see if we can spin around another 180. 3, 11, 5, 6, 15. And if you try to go another 180, you're going to be at 785 and that's past the 720. There are your 4 solutions. So notice I got, with the 15, 3 other ones, because there's 4 waves from 0 to 720. And with the 75, I got 3 other ones because there are 4 waves between 0 and 720. All right, interesting. I know these are interesting. Number 4. All right, so we look at this one and we got to think to ourselves. Now again, we're listing all values. Give all solutions in degrees. You're going to find that this is actually easier. So this wants every possible solution. Okay, well again, we have to isolate the sine function. Well, thankfully, all I need to do, there are 9 of them on the left and 2 of them on the right. So here, I'll show it to you. I'm going to add a negative sine 2 beta to both sides, right? And that makes the left side now 7 sine 2 beta. See, things we learned way back in pre-algebra, right? When you have variables on both sides, get all the variables on one side, right? And now we want to move the 7. So we're going to divide both sides by 7. So 2 beta is going to be sine to the -1 of -3/7. Okay, punch that in. -3/7 inverse sine. And I got -25.4 degrees. 2 beta is approximately -25.4 degrees. Okay, divide that by 2. And now beta is going to be, and again, I'm just doing it in my calculator, -12.7 degrees. Now, generally when we list all values, we don't like to list negative values. So we need to list this in a way that gives the positive value. So let me again apply the radial view and I'll show you where we're at. Notice our period is 180 degrees, right? Because of the 2, right? 2 waves in every normal 360. So that means this is 0 or 180, halfway is 90, quarter is 45, 3/4 is 90, plus 45 or 135. Okay. We have a reference angle of -12.7, right? Right here. So let's get the positive angle from that, which would be the 180 minus the 12.7. And I'm just going to punch that in, 180 minus 12.7, and that's 167.3. Now, because we want all solutions, 167, whoops, 0.3, 167.3. And do you remember what to put after it? So again, all solutions in degrees plus, and I hope you put 180n, right? The period, and then n is how many times you go around. And n could be negative numbers as well as positive numbers. And that gets us all of the values. Now, just to be clear, this is exactly the same thing as -12.7 plus 180n. These two are exactly the same. However, the positive 167 is the technically correct way to do it with the positive coterminal angle. All right, let's get the second value, right, in this first 0 to 180. So again, I need a reference triangle, right? So a -12.7, notice my sign is negative in quad 4 because the opposite is negative. Where else is the opposite negative? In quad 3, right? So that reference angle of 12.7 is right there. So how much is it, watch, from here all the way to there? So it's the 90 plus the 12.7 for 102.7 is our second value. So 102.7, and once again, to get all values plus 180n, and there's number 4. All right, challenging, I know. Hope you're doing well. Let's look at number 5. All right, again, we're showing all solutions, in radians. So I threw a radians in on you, but that's okay. You need to practice. Again, the book does all radians, but I know you think better in degrees, and that's why I've been working mostly in degrees, but we should be able to at least do a problem or two in radians. Okay, so again, let's isolate the cosine function. So I'm going to divide both sides by 5. So now I have cosine 1/2 x equals, 1/2 x equals cosine the -1 of -3/5. All right. So 3/5 negative inverse cosine, and I got 1/2 x equals 126.9 degrees. Now again, I'm going to leave it in my calculator because I want to now multiply both sides by 2, and we know the measure of angle x will be approximately equal to 253.7 degrees. All right, first answer. Now, we got to convert this thing to radians, and so, but I'm going to do everything in degrees, and then I'll convert it to radians. That's the way I prefer to work. I would recommend you do it as well, but you can convert to radians right away if you want. You can put your calculator in radians, but it's going to get tricky. All right, we have to take into account now the period. Notice now we get half a wave in a normal 360. So what is the period? 360 divided by 1/2, or 720 degrees. So a normal wave is 720. So again, watch what I do over here. 0, 720. Halfway, 360. Quarter of the way, half of the 360, 180. 3/4 of the way, 360 plus 180, 540. And now I'm set up. Okay, so this first one, 253.7, if I can read my own writing. Okay, so where's that going to be in here? Oh, I don't know. Somewhere about in there, right? 253.7. Okay. And we want all solutions in radians. So I'm ready to finish this one off. Do you remember how to convert to radians? So remember, it's going to be pi over 180. And in this case, we're going to multiply out the pi because we already have a round off in decimals. So we might as well just get it completely with the pi multiplied out because the front number is not going to be exact anyhow. So 253.7, 253.7, I should have left it in my calculator, but that's okay, times pi, and then divide it by 180. What did I do here? Let me try that again. 253.7 times pi divided by 180. Okay, and generally we're going to round to 1 decimal place. You can go to 2 if you want. But x, let's go back to blue, x is going to be approximately 4.4. If you went one more decimal place, 4.43. Now let's go one more, 4.43 radians. So because we want all solutions, 4.43 radians, we then need to add the period in. Well, be careful, we're in radians, right? So 360 degrees is how many radians? 2 pi. So 720 degrees is how many radians? 4 pi. So this is plus 4 pi n. So be careful there. You got to get that correct as well. Okay, that's the first angle. Remember, we have 2 within this normal period of 0 to 720. So let's find the second one. Okay, this requires knowing the reference angle. 360 minus 253.7. And that's 106.3. Now I need that because, again, I'm dealing with the cosine. The cosine is negative in quad 2, because the adjacent is negative, and the cosine is also negative in quad 3. So here's my reference triangle, and there's my 106.3. So I'll do this one in black. So watch, 180, 360 plus 106.3. So 360 plus 106.3 is 466.3. And again, they want it in radians, so now I'm going to convert it times pi over 180. So 466.3 times pi divided by 180, and I get 8.14. 8.14 radians. And then again, to account for the period, plus 4 pi n. Now we have all solutions in radians for this trigonometric equation. All right, 5 out of 6, 1 to go. All right, no, we're a little long here, but we're almost done. So hang in there, just about there. Let me get this out of the way. Don't think I need it. Uh-oh. 2 of them, huh? Grand finale. Cool. All right. So last one, we've got 2 things multiplied. Now, this one's set up well because it equals 0. If it didn't equal 0, we wouldn't be able to solve this. Not straight up and easily. But this is akin to a quadratic equation. So let me show you what I mean. If I had x squared minus 9 equals 0, I can factor that in x plus 3 times x minus 3 equals 0, and then I can set each one equal to 0 and solve, right? Because I have these 2 things multiplied that equal 0, so therefore they have to equal 0. So see how I have these 2 things multiplied to equal 0. So that's the basis of what we're doing here. So let me see if I can get rid of that real quick. Okay, so first one, sine 2 alpha minus 3/5 equals 0. There's our first equation. All right, now this one has its own period and it involves the aspects of the sine. So I'm going to do it first and then I'll come back to the cosine. Okay, so add a positive 3/5 to both sides, right? I set it equal to 0, and now I'm going about to isolate the sine function. So now I'm at sine 2 alpha equals positive 3/5, and then again, I'll do sine to the negative 1, right? So let's punch that in, 3/5, sine to the negative 1, and I get 2 alpha equals 36.86, etc. degrees, or 36.9. And now I'm going to divide by that 2. And so alpha is going to be approximately 18.4 degrees. So approximately 18.4 degrees. Now, I got to take note of the period, and I have to take note of what domain do they want us to give the values over. Okay. Period. You got that 2 there. So the period, 2 waves in every 360, right? So the period is 360 divided by 2, or 180 degrees. So that means over the 420 for this one, I have 4 waves, and I should expect 4 values, 3 more with that 18.4. So let's do this one first, then I'll do the second one. Okay, so here we go with the, and this is the first one of this sine. All right, hang in there, I'll show you. Okay, so 0 to 180, right, period, halfway, 90, quarter, 45, 3/4, 135, right? We've done that a few times now. Okay, 18.4, somewhere in here, 18.4. Now, working just off of the 18.4, and I'll be able to erase, so let me show you the next values with the 18.4. Go all the way around again. So that's 18.4 plus 180. So I'm kind of in the way here, so I'll do it down here. So 180 more, and my second value is 298.4. All right, so I'm at 18.4, 298.4. Now I got to go all the way to 720. So I'm going to spin around again, another 180. And now I'm at 478.4. 478.4. All right, and then I'm going to spin around another 180. 658.4. 658.4. And if I spun around another 180, I'd go past the 720. Okay? Again, you see how that works? All right, I hope so. All right, so that's just the one angle from the zero off of the sine. So again, I gotta, now I need you to understand this, right? Go back, right? Or sine, where this is 180, this is 90, right? And we got this 18.4 somewhere in there, but see how we also have this other value? So again, coterminal angle, or you can do it this way. I know it's going to be 90 minus, but again, our sine opposite is positive, hypotenuse is positive, sine is positive. Where else is the sine positive? In quad 2, right? Where the opposite is positive, the hypotenuse is always positive, right? And this 18.4 is in there. So what is this other angle? 90 minus 18.4. So punch that in. What is that? 108. 90. Okay, what did my calculator do? 90 minus 18.4. 71.6 degrees. Okay, so that's a second set here with the sine. But notice I can spin around another 180, so let's add a 180. 0.615, 251.6. Doing these fast, so hopefully I'm not going to make a math error here. Spin around again, another 180. 431.6. And I'm guessing I get one more, my fourth one, right? Because I get 4 waves. 61145, 611.6. All right, now those were all off of just the sine. We got 8 values off of the sine part. Now I got to do the cosine part. Oh, brother. That's okay. We're getting there. Use my black. So again, I'm going to do cosine alpha plus 1 equals 0. And I'm going to add a -1 to both sides. And alpha is going to be cosine to the -1 of -1. Now, thankfully, this is a nice value. So you punch that in, or you should know it. I mean, you should, but maybe you don't. But you punch it in, and your calculator says alpha equals 180. All right. Now, I got to be careful. Let me be clear. I want you to watch what I'm going to do here. Notice the period was 180, but that was for the sine because of the 2 there. What is the period of the cosine? Well, we don't have a 2 there. Technically, we have a 1. So the period of the cosine, period subscript cosine, is 360 degrees. So be careful. Now, the radial view is tougher on this one. But let me set this up. 0, 360, halfway 180, 90, 270, and we got 180. Because we have a cosine of -1, we have to have the adjacent equaling the hypotenuse. So watch, let me try to show this to you as best I can. Right, the adjacent here is negative over the hypotenuse, and it's a certain value. Notice how the adjacent is getting longer, and the adjacent is getting longer, until finally you hit this axis, and you have a negative adjacent over the same value of a positive hypotenuse, which gives you a -1 at 180. That's not the easiest way to figure that out. If you go back this way, much easier. Where is the cosine? A -1 at 180. So the radial view much easier. And notice now, so my first answer is 180 degrees. And what is my next answer? Another 360 more. I got to add that period because, again, I'm going all the way to 720. And what is that? 540. So those are my last two values. 180 due to the cosine and the 540 due to the cosine. This thing had 4, 8, 9, 10, 10 values. And I think your worksheet had them listed vertically, and I think I had 10 spaces to help you out. But that's why there are 10 solutions. All right. I know it's a long video, but hopefully it was comprehensive enough. I tried to take my time and explain everything fully for you, and I hope that's a help. And hey, email me. I'll email you right back, and we'll try to get things figured out, try to help you out. Remember, though, what I said in the beginning. The chapter involves law of sines, law of cosines, the area formula, some of the key trigonometric identities, and then trig equations. And these last few are the toughest of the tough. Am I going to give you 5 problems like this? No way, I can't. You won't have enough time. So again, temper where you study and study it all. And by the way, stop missing those questions on the first page of your test. Memorize the material you're supposed to memorize. Anybody can memorize it. You don't memorize it because you don't memorize it. So memorize that stuff. Get the memorization down, and then you're ready. All right, gonna have a quiz coming, test. Get you ready for this chapter. I hope you do well. Thank you.